No?
Isn't it the same as local host?
No. It means listen at any of my interfaces. And when I say interface, I mean this is one of the arguments that comes to the bind function. So bind, and the other one is port. So if you have one network card, it could give you an interface. For example, on Linux, you can get a list of interfaces by running ifconfig. On Windows, you can write ipconfig. And interfaces usually have names. For example, ETH0, ETH1. We also briefly mentioned the loopback interface. So that one is named LO. It could be LO0 maybe, but that's what it comes from. If you have a Wi-Fi card, then that interface will probably be named WLAN0. And if you have more, it will be 0, 1, 2, 3, etc. If you have a VPN connection, it will probably be named TUN0 and so on. When you have a server listening at this address, it means that anyone can connect to it from any network, from any interface. If it's only 127.0.0.1, for example, then it will only accept connections from clients running on the same machine. What other questions do you have? Yeah?
What if it's 127.0.1.1?
You will be able to connect to it locally if you type telnet 127.0.1.1 and that port number. And it might not work if you try to connect to it by typing telnet 127.0.0.1 and that port number.
Probably it won't work if we type localhost.
Maybe. You should try and see. Any other questions? Maybe you were, you went for a walk and you thought about what I told you previously. And you want some clarifications. Let's get back to what happens on the client and the server in the sockets API. So you first call the constructor, telling your system that I want you to make a new socket and give it to me. On the server, you then bind that socket to an interface and the port number. For example, you could say, I want to bind it to 0.0.0.0 at port 2005. Let's make it 2015 to commemorate this year with a few more zeros added to it. When you bind it, you can run Netstat, and you will see that it's not yet listening. You're not accepting connections when you do that, but the moment you call the listen function, that's when you run Netstat, and it will say you have a new server listening at that port at this interface. This function takes one argument, which is a number that tells you what the queue size is. And the queue size is about the clients who are attempting to connect right now to the server. And when I say right now, treat it with a grain of salt. It's pretty much the same as immediately, as we discussed in the previous class. So let's say I am the server, and there is one client connected to me. You realize that when you accept the connection, this does not happen immediately, even though it is perceived as such by a human being. What actually happens? Whenever you accept a connection by calling the accept function, and the client connects, the software running here receives this incoming connection request, and a few things have to happen. First of all, it has to allocate a new socket. So it has to make a new socket which has to have a port number. So it has to choose which of the port numbers it will assign. And how does it make that choice? It chooses a port randomly, or it has some list of available ports and it takes one of them. If it has the list, it means that there has to be some data structure. You have to go into that data structure, find what element is available. If it's a linked list, you have to go starting from the head of the list and then go to the next node, etc. So it takes time. And then when that happens, you allocate it, you create some data structures, you initialize some flags. So all of these actions take resources. Megabytes, gigahertz, etc. So imagine that while one client is connecting and the server is going through all these steps in the sequence to actually accept the connection, another client wants to connect too. What is going to happen?
Allocate a new socket.
Well, the same thing is going to happen, but it's not going to happen in parallel. It happens one step at a time. So if you have 1, 2, 3, 4, and more clients willing to connect, while this first one is being processed, this 1, 2, 3, 4, yeah, they will be queued. And when this one is processed and the connection is alive, this one will be processed, and this one, and then that one, etc. So that's the queue size. Let's say it's going to be 5. So it will be able to keep them waiting for a while, 1, 2, 3, 4, 5. 5 of them. If this one tries to connect, while these are currently in the queue is full, this one will get some response like connection timed out, the server did not respond, or something along those lines. Of course, all these steps happen fast, so we perceive them as immediate. But keep in mind that it's not immediate. There is a finite amount of time that has to flow for this connection to be fully accepted. So that's what this queue size is about. When you call the accept function, several things happen, and one of them is that this function blocks. What does it mean that a function is blocking? We have 2 answers, and I'm going to ask you. I assume you don't know. Who else can tell me? What is a blocking function? Maybe you?
Well, as I understand, it's blocking the connection. Like,
so
if there is an incoming connection,
mm-hmm.
it doesn't want to.
I can say that a function can be blocking not only if it's in any way related to networks. So you could have another function which also blocks. Did anyone ever use a function called sleep?
Yes.
Okay. So let's say you have your code. One line, another, then here you call sleep, and then you have more lines. And let's say you are running a debugger. So you placed a breakpoint here. The program stopped. You press next, it moved on to this line. You pressed next, it moved on to that line. Then you are here. And when you press next on the sleep line, will it move to this line below it?
You will be waiting for the time.
Yeah, it will wait for a while. In other words, it will block the execution of your program until this function finishes, and only then will it move on to the next line. So the same thing happens here. When you run your server application and you call this function, and let's say above it you have print 1, 2, 3, and below it you have print ABC. So when you run this function, it will print 1, 2, 3, and then nothing happens until a client connects and this function returns. And when the connection is established, only then will you see the other line print ABC. So that's what a blocking function is. When you run except, it blocks until someone connects. However, keep in mind that sockets can be blocking and non-blocking. By default, if you don't do anything, it will block. However, there are a bunch of functions, such as set blocking with true or set non-blocking with false. I don't remember exactly. If you call it explicitly, then you can change the behavior. There is also a function called set timeout. And you could set a timeout to 0, meaning it will wait forever. In other words, it will be blocking. Or you could say set timeout 5. It will wait here for 5 seconds. And if nothing happened, it will print ABC. So when you call this function and the client connects, it will return an object, which is a socket, which corresponds to the connection with this client. And you can use that socket from now on to send and receive messages from this client. Your original listening socket will continue to exist and continue to accept new connections if you do this in a while loop. Otherwise, it only accepts one, moves on, and that's it. Yeah?
Does the server create a new socket every time a client connects?
It creates a new socket every time you call the accept function and the client connects. If you don't do this, they can try as hard as they want. They can press enter like this, and it's not going to connect. They can even reinstall Windows. It's not going to reconnect, to connect.
Not even restarting the computer?
Well, I heard about it, but I'm not sure it's going to work. What else? What other questions do you have? Okay, we move on. Once your connection is accepted, there are a few more things you can call. There is one function called send. You give it your data, some buffer, and that data will be sent to the client. And there is also a function called receive, I think it's recv, where you tell it some number of bytes that I am willing to receive. So for example, if the client sent me the string hello, and I called the receive function with 1 as an argument, it will only receive this first byte. If I call it again with the value 1, it will receive E, and so on. I can also say receive 1,000 bytes, and it means receive up to that many bytes. So if the client only sent me 1, 2, 3, 4, 5 bytes, I will receive just the 5 bytes. It will not wait until someone sends me more stuff and it reaches the number 1,000. Does it make sense?
Do these functions work in the same way for TCP and UDP?
Yeah, they do. And there could be some quirks which you need to take into account, but I think it's better to discuss them when we get that far. And when you're done, you can call close, and the connection closes. Let me tell you a few more things about the client side of the problem. Here, just like on the server, you can call the socket constructor to make yourself a new socket. Then you can call, so let's say S is our new socket. Then you can call S connect, and you give it an address and the port number, assuming that the server is already there. And then you can do socket send. You can also do dot receive. And you can interchange data between these two peers. And when you're done, you can call close. Keep in mind that once the connection is established, you don't say that the server is more important than the client. They are equally powerful peers. The client can send and the server can send. The client can receive and the server can receive. Either of them can call the close function and terminate the connection. So the server is only different in the sense that it's the one who accepts, is the one that listens for a connection. But once it's established, it's there and it will continue to stay alive. If it's a TCP connection, it will stay alive indefinitely until someone calls close, or until someone turns off the power supply or disconnects the network cable, etc. So unless anything wrong happens,
Or keyboard interrupt.
or someone kills the process, for example, unless there is some external factor that wants to explicitly kill this connection, it will stay alive until one of the peers decides to close it. And in fact, at some point in the future, we will discuss the details of how TCP works, and you will learn that when one client says, I want to close the connection is not closed until the peer says, okay, I agree, let's close the connection. But let's take it one step at a time. Normally, if we had a projector, I would hook up my computer to the projector and walk you through the steps of creating a client and the server. But since this is not an option, what can we do?
Do it ourselves with your code.
Okay. Maybe we could bring a projector? I mean, if you want to. Well, then let's do this. While someone is thinking about, no, while I'll tell you about the next assignment, you then think about the projector if you need it. You had a question?
Actually, not a question.
An answer.
We can take a team viewer session.
But all of us would have to be in the same network.
Not quite. Everybody has to have internet connection. That's it.
Well, we would all be a part of a big network called the internet. We could do that.
It doesn't take time.
I think the projector is better because I can use it to point to things. So, is it an option to, we should have done this at the break.
You also can check out if 201 is free or not. So
The other room. Yeah, we could.
there is a projector.
Well, I think whoever is the one who goes to pick up the projector will,
Might check the 201.
yeah. But anyway, let's discuss what you have to do. Your mission in the first assignment is to write a server and a client. The server must be able to accept a connection from a client and implement several commands of your choice. For example, if the client sends the command time, the server will send back a response containing the current time. If the client sends some other command of your choice, the server will respond with that answer that corresponds to that command. There are a few more things to remember. The assignment itself can be found on info.raylan.net. If you go to that page, somewhere at the top, there is a link that says CPC or maybe network programming course assignments or something like that. Yeah, CPC labs. It's called SIPC labs. So you go there and you click on lab 1 and you'll see what the formal requirements are. So our next step is to do the projector thing. Where do we have to go to get it done? So everyone who has Python, run it. And I will tell you a few things about how to do things in this interpreter. If you prefer to do this in Ruby or something else, it makes no difference. The same functions should work as long as you adjust what I tell you to your syntax. Instead of some curly braces, use other flavors of braces. Some of you don't have computers. Maybe you could try this one. Is there anyone else without a computer? So, could you give me the marker again? One of the nice things about Python is that it allows you to run something and see the result of that action instantly, instead of having to compile it, and then run it and see what happens. So you can play with your program and grow it from 0 to something else by typing and observing your results in real time. So it's an interpreted language. It's much more user-friendly than many other languages on the planet. Yeah?
I have an organizational question.
Yeah?
How we should submit the lab works and
You have to submit your reports by sending me an email to the address I gave you previously. It has to contain your source code and a report where you explain what you did, how you did it, why you did it, and your conclusions. Your reports have to be written in English. You have to use a spelling checker and send me a nice, properly formatted data file, not some mumbo-jumbo you pulled out of a hat or out of a rabbit's ear, okay? Okay, so now you have a much better user experience, a bigger text, and a different color scheme. So is it readable to the people in the back?
Yes.
Yoo-hoo! So the first thing you do is you import the sockets module, which enables you to call a bunch of socket-related functions.
Do you screen recording?
No, I'm not doing any screen recording, so not yet. So I'm going to turn this into a screencast so you can view it in HD on YouTube for free.
Awesome.
I am now going to write the server. And as you remember, we start by creating a listening socket. And in this case, socket.socket means this thing from this module, which we've just imported. I can do it this way, giving it no arguments. It will use some default values, which happen to be good enough for what we are trying to do. And then you can check if this object is alive by doing this. Just type listening socket, and it says, you have this object at this address. Of course, in your case, it will be some other address. It's not relevant right now. What was the next step I told you we had to perform? Bind. Okay. So let me open another terminal window. I will do this. It tells me what my current interfaces are. The only one which does have an address is the localhost loopback interface. So I'm going to do this. Listening socket, bind, and at the input, it takes an address and a port number passed as a tuple. In Python, a tuple is a data structure with a fixed number of elements. You write them in brackets and you comma separate them. So the first argument in that tuple is the interface. In my case, it's this one, and in your case too. And the next argument is the port number at which we want to accept connections in the future. And let's do this at port 1, 2, 3, 4, 5. So now I did this. And here you can see the current output of Netstat in my system. I have a number of sockets in a listening state at port 22, SSH. Other ones, but none of them is at port 1, 2, 3, 4, 5, which we did on the other screen. What was the next step I told you about? I don't remember, but I can rely on you.
Make it listen.
Okay. Switch to the client side. Well, before we go to the client, we have to listen. We have to start listening. So listening socket.listen, and you say how long you want that queue to be. Let's make it 5. Okay. Now I'm going to switch back to Netstat, and I am giving it this argument here, L, which tells it to only show me the listening sockets. Now, you see something different. You have this 127001 at port 1, 2, 3, 4, 5. It's in a listening state, And the parameter that I gave it here, P, says, show me which process is responsible for this object. And it says, process ID 2688, Python. In your case, it's going to be some other process ID. And if you do this in Python, it will be that. These other ones are shown as 0. The process ID is not known because these listening sockets are managed by processes which were ran by another user account, not by this user. So if I do that, but with a sudo in front, then it tells me what program is responsible for that listening socket. So for example, now we know that port 1974 is used by TeamViewer. It wraps around and ends here. What else? CUPS. It's a common Unix printing system. And usually D in the end stands for daemon, server. So this is the CUPS daemon. SSHD, it's a secure shell daemon. SMBD, it's not somebody, it's Samba daemon. Samba is a file sharing service. What else? Well, we covered them all, and we see our process here. So now we have the current situation. I'm going to open another terminal window and move it here. And for now, I will be using Telnet as my client. So I do this Telnet 127.0.0.1, port 1, 2, 3, 4, 6. I type enter, and it says unable to connect, connection refused, and that's normal because we didn't see any listening socket at that port number. Now if I do 1, 2, 3, 4, 5, it says this, escape character is hat and that. Now, if you go back to this window, okay, let me do this again. Now let me, okay. On one hand, I want it to fit in one window, but on the other, I want it to look large. So now you've observed something new here. You have another connection on this line. So the local address is 127.0.0.1 with this port number. The remote address is 127.0.0.1 with 123.4.5. On the other hand, we have a new line where the local end of the socket is 127.0.0.1, 123.4.5, and here it's the same thing, but they were reversed. Why is this happening?
Because the same machine is the server.
Exactly, because in this case, both the server and the client are on the same computer. So they act as if they are on different machines. So let me draw this visually. The client is 127.0.0.1. At port, it was 4.4 something. And usually, the notation is address, colon, port number. And it is connected to the other end, which is 127.0.0.1 at port 123.4.5. So from the perspective of the server, this is the local address and that's the remote address. From the perspective of the client, this is the local address and that's the remote address. Okay. Now, the other thing that I should highlight right now is that while I was waving my hands and telling you stuff, nothing here happened. And if you run Netstat again, you will see that the connection is still alive, still running, and it will continue to remain in that state even if I do this until my battery on the laptop runs out. So let me try to send something to my server. So I'm typing a lot of things, and nothing happens. Nothing happens because I haven't yet accepted the connection, yet the client already managed to send some stuff. Where did that stuff go, in your opinion?
Maybe in a queue.
Maybe in a queue. Maybe it went to nowhere, and I'm just talking to no one. What actually happens is that all this stuff is buffered by the operating system's network stack, and when this thing eventually begins receiving, all this data will be visible. So let's try that. So I am now going to call the accept function. And it has returned right away, while I told you back in the other room that it's a blocking function. The reason it returned right away is because we've had this client already trying to be in a conversation with our server. Now, the accept function returned me something, which I stored in the variable that I called result. Now, if I just do this, result, it shows me what I'm looking at. So it's a new socket object. And how do I know it's new? Because this one is at this address, while the listening socket is at that address. And you can see that they are different. And when I say address, I don't mean IP address. I, of course, mean an address somewhere in memory, in RAM. And this socket object, I mean, the result returned by the accept function is a Python tuple that contains some info for it. The first element in the tuple is the socket itself. The second one is the address of the client who has connected to me. So I can do this. Result 0, and it's just the socket itself. Result 1, and it's the address of my peer, which is basically this. I can now do something that in Python we call tuple unpacking. So I will do this. Client, socket, and client address equals result. So now, what I just did is result 0 is mapped to this variable, and result 1 is mapped to this one. So in other words, client socket equals result 0. True. So let's see. Client socket dot receive, and I'm going to receive 5 bytes. And this function returned the first 5 bytes of my message here. If I call it again, it gives me the next 5 bytes, and so on. I can call it in a loop. For example, I could do this. For I in range 0 to 10, client socket receive, and receive 2 bytes at a time. So you see, it ran that loop 10 times, or as many times as I asked it to, and you see all these 2-byte chunks from this response. Now, we are not actually doing any networking right now because we are talking to someone on the same machine. However, you can use exactly the same code. And if instead of 127.0.0.1, you would connect to some other server, it would work. So the good news is that throughout this course, you don't really need an internet connection. You just need a computer with some programming language on it, and you can write your own client and server, run them on the same machine, talk to each other, and it will work. And then if you take that code and run it on separate computers, provided that they are in a network where they can see each other, it shall work without any change. Now, let's try something else. Client socket send. What do you think is a noble message to be the first one to send back to a client?
World.
Hello world?
Hello client.
Hello client. Okay. Hello client. What's going to happen when I press enter in this window? It should appear on the other side where our client currently is. Yeah. And you also observed something else. It says 12. Is it the number of the day? Is it the answer to life, the universe, and everything? Is it someone's favorite number?
You don't actually know, but it's the number of bytes that are sent.
Mm-hmm. Well, an attentive observer will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you read the manual where they tell you what this function does and what it returns, it says this number tells you how many bytes were successfully sent. So I could send a very long message, but it's not necessarily going to arrive exactly in that form. Maybe for some reason, sometimes, only some of it will be delivered. So it's a good thing to maybe look for, to check the return value and compare it with your expectations. This way you know if all of your message, if the message was delivered entirely or maybe not. Did everyone manage to replicate this behavior? Who did not succeed in doing this? Okay, which?
I only had one problem. I couldn't find a connection in Netstat.
Uh-huh.
But everything else worked.
So you couldn't find it until?
Actually, the parameters on Mac does not work. These parameters you've shown there, but it's okay. I mean, we can do the task without that.
Yeah, but I did it without parameters. And
Yeah, you can see all the connections without giving the parameters. It's okay.
All right. Well, what about you two, the two of you?
Telnet doesn't work at all.
You don't have Telnet.
I have in Windows. It works in CMD, but in Python it doesn't work.
Well, of course it doesn't work in Python.
Why?
Because it's a standalone program. It's not a Python function. You see what I did here? I opened the new terminal and ran Telnet. I didn't open a new terminal, run Python, and then type Telnet in that terminal. So, yeah, but you should have said that right away, and I would have explained.
Same thing.
Uh-huh. Okay.
In govern the work, we should put all this client into a script, right?
Yeah. And it is really important to pay attention to what happens on the board, because sometimes you could miss a parenthesis, a semicolon, and nothing works.
Yeah, and you don't have automation.
Not
Python shell.
out of the box, no. But you can use IPython or BPython, which are slightly fancier shells, and they give you some bells and whistles. How much time do we have left? 10 minutes. Well, 4 minutes. Let's try something else. Listening socket accept. So I went back to my server. I called the accept function of the listening socket, and you see what it does here? It's blocking right now. Because normally, if you type a command, it's being executed and you see those 3 characters, meaning that Python is now waiting for your new input. Whereas now, it's blocking. So I am going to fire up another telnet window, and I'm going to make it of a different color. I'm going to make it white so we can tell the difference between them. And I will do this again. Telnet 127.0.0.1, 123.4.5. Okay. I have 2 clients. And you see that the accept function finally returned a result. And you see those 3 characters here. It's waiting for new commands from me. Now, I want to take this client socket and do something with it. Inside the Python interpreter, you can always rely on a built-in variable, which is the underscore, which means the result of the last function that you just called. So I'm going to do this. Client socket 2 equals underscore 0. Wait. Underscore 0. And now, we have this. So this is the second client socket. This is the first one. And at first I was surprised they have the same address, which is not supposed to be the case. But then I realized that the line was just not wide enough. So the address is continued on this end, and you see that they are different. So we are, in fact, now dealing with 2 different clients. But for the first couple of seconds, I was confused. So let's do this. Client socket 2.send. What's the second best thing you could tell to a newly minted client?
42.
Buy?
What do you want to buy?
Okay. So you see, the message arrived here, but not there. And if I do this, the data were sent. They are somewhere in some buffer, but not yet in this process. So I could do client socket 2 receive. Let's see what happens if I give it no arguments. Aha, it says, you gotta give me some arguments, man. So I'm gonna give it a very big argument. So although I told it to read 12,000 bytes, it only returned 1, 2, 3, 4, well, less than that, obviously, because receive will read up to that, but not exactly that many bytes. Yeah?
I got a strange behavior, a bunch of slash types of words. I think for every byte.
Did you send the Unicode string?
Maybe. I didn't send anything. I just had the text written here, and then when I.
Well, someone sent those bytes to your process.
Okay.
Now, observe that although we only sent poitre, there is something additional here in the back, \r\n. Where did that come from?
From the enter key.
Yeah, it came from my physical action of pressing enter. When I typed that, I pressed enter, which is mapped to \r\n. And these two characters come from the good old days of typing machines, where you would have a device like this one with a lot of buttons, and there was a carriage. And as you type, this thing moves forward. And if you saw it in films or maybe used one on your own, when you reach the end, you press, oh, wait a second. When you reach the end, you press a button, and it rotates the paper up, and then you have to manually move it back, the caret. So \R means return, carriage return. In other words, you put the cursor back to the beginning of the line. And \N means new line, rotate the paper up. So for backwards compatibility reasons, with old school typing machines, nowadays you have \R, \N on computers. You may also observe that, for example, on my system, which runs Linux, you have \R, \N. Somebody else might have just \N, and someone else might have just \R. It depends on your platform. What other questions do you have? Yeah?
Can we configure the Telnet client in such a way that he will delimit the message we write from the client and the message we receive without sending a new line to the server?
I have no idea. We can read the manual and see if it has anything to tell us on that front. By the way, you noticed that when you connect with Telnet, it says escape character is that. What is it for? To close the connection. So right now, whatever I type is being sent to the server. But if I want to do something locally, I press Control that, and you see it reverted me to the Telnet prompt. So now whatever I type is not sent to the server, but is interpreted locally as a command. So I could do, let's see if close works. Yeah, it does. I have my other client here, and if I press Control C, for example, to stop the process, it doesn't do that. Let me try something else. Control A, same thing. So if I do that, it prints me a bunch of bytes. So this XFF means this is the hexadecimal representation of the character that I received, which was FF. So basically, Control C is FF. Huh, strange.
Or it's just control?
FF, F4, FF, FD. Oh, wait a second. This entire sequence, you see, it's a repeating pattern. So every Control C character is represented as a sequence of a bunch of bytes. So when you said that you had some 04 bytes,
Yes.
maybe you pressed some hotkeys which were interpreted as characters.
Maybe. But it was only one particular hotkey, like 50 times.
Maybe you did, but you didn't do this 50 times.
No, I didn't.
Well, that's interesting, which is why it's really important to be a good observer. When something happens, you need to know why it happened. And the only way to answer that question is to, first of all, be familiar with computers, not be afraid to open the manual and see what happens in the background, and of course, pay attention to the details. Because we don't have much time now, I am not going to tell you the joke about the doctor who did not pay attention to details, but I will do